Friends, welcome back to our channel. Before we start our today's session, I want to remind you one correction. In the last session, we have seen this first question. A ring R plus dot is a ring with unity if there exists an element 1 belongs to R such that 1 into A is less than 1 for all A belongs to R, 1 into A equal to 0 for all A belongs to R, 1 into A equal to A. Here there must be A. For all A belongs to R, 1 into A is greater than 1 for all A belongs to R. By identity law, we know A star E is equal to A is equal to E star A. Here we use a binary operation multiplication. So A into 1 is equal to A into 1 is equal to A is equal to 1 into A. That is why option C is correct. Please note this point. To our today's session. Today also we discuss some more questions of Government Degree College Lecturers Recruitment Test 2020 conducted by Appsc. First question is, in the field A plus B root 2, where A and B both are rational numbers, with addition and multiplication, the multiplicative inverse of 5 plus 3 root 2 is, options are A 5 by 7 plus 3 by 7 into root 2, B 5 by 7 minus 3 by 7 into root 2, C 5 by 43 plus 3 by 43 into root 2, D 5 minus 3 root 2. Here the multiplicative inverse of 5 plus 3 root 2 is option B, 5 by 7 minus 3 by 7 into root 2. Now we see the proof. The multiplicative inverse of 5 plus 3 root 2 is 1 by 5 plus 3 root 2. On rationalizing the denominator, 1 by 5 plus 3 root 2 into 5 minus 3 root 2 by 5 minus 3 root 2. So 5 minus 3 root 2 by A plus B into A minus B gives A square minus B square. 3 square 9, root 2 whole square 2, 9 into 2 18, 25 minus 18 is 7. Therefore the multiplicative inverse of 5 plus 3 root 2 is 5 by 7 minus 3 by 7 into root 2. Option B is correct. Second question. If F is a homomorphism of a group G into a group H with the kernel K, then kernel is a subgroup. Kernel is a subgroup of G. Option B is correct. Here the given options are A group, B subgroup, C identity element, D isomorphism. Answer is subgroup. Kernel is a subgroup. So option B is correct. Third question. The order of a subgroup of a finite group is a divisor of the order of the group. Lagrange's theorem. We know order of subgroup of a finite group divides order of the group. So that is where option A is correct. Here the given options are A group, B subgroup, C permutation group, D infinite group. Option A is correct. The order of subgroup divides order of the group. So order of dash, here it is group. Question. If omega is a complex cube root of unity, then there is a generator of a cyclic group of order. Option A 2, option B 3, option C 0, option D 1. Option B is correct. Since we know omega cube is equal to 1, therefore order of omega is 3. So therefore order of the generator omega here in this cyclic group 1 omega square. In this cyclic group, both omega and omega square are the generators. The generator order is here, omega generator order is 3. Omega square order also 3. Next, coming to fifth question. Let G be a finite cyclic group and A comma B belongs to G if order of A and order of B are co-prime. Co-prime means GCD is 1. So order of A and order of B GCD is 1. They are co-prime, it is given. Then option A, order of AB equal to order of A into order of B. B option, order of AB is not equal to order of A into order of B. Option C, phi of AB divides order of A into order of B. Option D, order of A equal to order of B. Option A is correct. Order of AB is equal to order of A into order of B. Anyhow, by order of GCD of order of A and order of B is 1. So that is why order of AB is equal to order of A into order of B. Question. Every positive integer can be expressed as the dash of prime factors. Every positive integer can be expressed as the product of prime factors. Option A is correct. Here the options: A product, B addition, C subtraction, and D division. So every positive integer can be expressed as the product of prime factors. So the answer A is correct. Prime factorization, as we all know, every positive integer can be expressed as the product of prime factors. Seventh question. If P and Q are twin primes, then PQ plus 1 is a dash. Option A is correct. Perfect square. Option B imperfect square. Option C cube root. Option D unit root. Here P and Q both are twin primes. For example, we take 3 and 5 are twin primes. That means their difference between these two numbers is 2. So when we multiply, suppose if it is P and this is Q, when we multiply these two, 3 into 5 plus 1. So 15 plus 1, 16. 16 is a perfect square, 4 square. So PQ plus 1 gives a perfect square. So therefore option A is correct. Question. If an integer P greater than 1 is prime, then P divides. Option A P plus 1 factorial plus 1. Option B P minus 1 factorial plus 1. Option C P plus 1 factorial. Option D P factorial plus 1. Option B is correct. By Wilson's theorem, we know if P is prime, P minus 1 factorial plus 1 is congruent to 0 mod P. That is why P divides P minus 1 factorial plus 1. So option B is correct. Ninth question. If A is congruent to B modulo M and B is congruent to C modulo M, then A is congruent to C modulo M holds the which property? A reflexive, B symmetric, C transitive, D non-transitive. Option C is correct. A is congruent to B and B is congruent to C. Therefore, A is congruent to C. That is a transitive property. Option C is correct. 10th question. If X and Y be two numbers and P, Q be their HCF and LCM respectively, then option A XY greater than PQ, option B XY equal to PQ, option C XY less than PQ, option D XY minus PQ is greater than 1. Option B is correct. Product of any two numbers is equal to product of their LCM into GCD or HCF. So X into Y equal to PQ. Option B is correct. 11th question. If A and B are any two integers, not both are 0, both are non-zero integers, and K is any integer, then GCD of K, KB is option A modulus of 1 by K into GCD of A, B. Option B mod K into GCD of A, B. Option C K into GCD of KA, B. Option D K into GCD of A, KB. So option B is correct. GCD of KA, KB is mod K times of GCD A, B. Option B is correct. 12th question. What is the highest power of 3 contained in 40 factorial? Option A 6, option B 8, option C 12, option D 18. We see the proof of this question. Option D is correct. 18. Highest power of 3 contained in 40 factorial is 18. How we see? Highest power of 3 in 40 factorial. Here P is equal to 3, N is equal to 40. First we find out the step of N by P. 40 by 3 gives 13.3. That means integral part is 13. So step of N by P is equal to 13. N by P square we see 40 by 3 square. 3 square is 9. 40 by 9 is 4 point something. So therefore integral part here is 4. Here is integral part is 13. So integral part of 13.3 is 13. Integral part of 4.4 is 4. Now we find integral part of N by P cube. 40 by 3 cube. 3 cube 27. So this is 1 point something. Integral part is 1. So adding all this, 13 plus 4 plus 1 gives 18. Therefore, highest power of 3 in 40 factorial is 18. So, option D is correct. 13th question. The number 5117247, this is 7-digit number, is divisible by which number? A 6, B 12, C 9, D 7. Option C is correct. It is divisible by 9. So by adding all the digits in this 7-digit number, 7 plus 7 14, 14 plus 6 20, 20 plus 7 27. 27 is divisible by only 9 here. That is why this number is divisible by 9. It is not divisible by 6, 12 and 7. So therefore answer C, that is it is divisible by 9 is correct. 14. If A and B are two elements of a group G, then AB equal to BA, A into B inverse is equal to B into A inverse. Option C, AB whole inverse is equal to B inverse into A inverse. Option D, A inverse into B is equal to B inverse into A. Option C is correct. AB whole inverse is equal to B inverse into A inverse. It is just a group. Suppose if it is abelian group, AB whole inverse is A inverse into B inverse, we could write like that. But here it is just a group. AB whole inverse is equal to B inverse into A inverse is the correct answer. 15th. Let H be a subgroup of group G and N is a normal subgroup of group G. Then here the options are A, H union N is a normal group. B, H into N is a normal subgroup. C, H intersection N is a normal subgroup. D, H union N is not a normal subgroup. Option C is correct. H intersection N is a normal subgroup of H. This is the correct answer. In today's session we have covered most of the questions from number theory and group theory. Hope you understood this class. Thank you.